Hi, and welcome to this video for the Leaving Cert Ordnance Level 2020 Paper 1, and this is question 4. So if you want to copy these notes I'm working off, just send me an email at shanetroy@gmail.com, and if you click the subscribe button you'll get access to playlists for 2020 and previous years. So this is question 4, and it's a wordy one. Just get stuck in. Now, the Golden Gate Bridge in San Francisco is constantly being repainted. It is estimated that the surface area of exposed steel that needs to be painted is approximately 10 million square feet. So 10 million, so 6 zeros in a million, and that's square feet. So that's going to be important. Now, part 1 here says, given that 1 meter equals 3.28 feet. Convert the surface area of the bridge into meters, so square meters, giving your answer in the form of a by 10 to the power of n, where the a is between 1 and 10, and the power is positive number. So in a sense, don't worry about this. It's always between 1 and 10 in the Leaving Cert. So you just write it in normal scientific notation. And the last bit here, you've got to worry about these two significant figures. We can worry about them later on. Okay, so we're simply looking here at, we're trying to find the area of this. Well, look, the area of this shape, now if it's a square, it's going to be length by length, but let's just go with length times width. Now it just happens that the length, you could say it in meters, is 1 meter by 1 meter, which is 1 meter squared. Or you could express that in feet, so 3.28 by 3.28 is equal to, I should have my calculator open, and I do, it's just on my second screen. Okay, and now, so it's 3.28, now technically it's squared, so look, let's just save myself the time. And I get this 10.7548. Okay, 10.7548. Now, if you make the connection there, these are two different units, but this is the area given in meters squared. This is the area in square feet. So they're equal to each other. So 1 meter squared is equal to 10.7548 square feet. That's a valid statement. Now we're being asked here to find the area of the bridge in square meters, not in square feet. So we have what 1 meter squared is in square feet, but we do have the actual area of the entire San Francisco Bridge. So we're kind of asking, how many of these in this? And if you make that leap, okay, you look, you're practically finished. So what's 10 million divided by 10.7548? Now I'm going to go to the answer to the next page, okay, because I have it done out here. And I got this 929,506.2, whatever. Now it's saying to write that in scientific notation, but it wants this, the first number in the scientific notation, to be between 1 and 10. That's literally what this is standing for. At the moment, my decimal place is here. So if I want this number to be between 1 and 10, I have to move this once, twice, 3 times, 4 times, 5 times. And that's where I get this 9.295, blah, 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 by 10 to the 5. That's all I'm doing with scientific notation. If I had moved this to here, it would be, what, 92.9, whatever, by 10 to the 4, because I only moved it 4 times. But I moved it 5 times here. That's why I get this by 10 to the 5. Basically done. They want now the answer in 2 significant figures, not 2 decimal places. Okay, and you might see people here write 9.30. Okay, to 2 decimal places. But significant figures and decimal places, whilst they're similar in a way, they're not the same thing. Any number is significant. It all, in terms of what's not significant, involves the zeros. But in this situation, you just have to have 2 numbers, okay, and you're rounding it to that. So 9.2, the 9 here is what matters. It rounds the next number up by 1, and I get 9.3 by 10 to the 5 meters squared, which is an approximation, but that's what it is. Happy days. Okay, so all we did was find the area, okay, formula, which we're not given. We then went, look, what's the area in feet? What's the area in meters? And made the connection that they are equal to each other. Once we made that grasp, we went like, I'm given the area, the surface area of the bridge. Is how many of these are in that? Okay. Once I had that calculation done, I'm in the home stretch. It's just a matter of expressing it in the right way. If I do, then my last little task is, can I express it to the right number of significant figures? Happy days. Okay. So if I move on, now part 2 here is only worth 5 marks. And they say a litre of paint used on the Golden Gate Bridge will cover approximately 5 square feet. The paint comes in 25 litre tins. So you have tins, okay, there's 25 litres in there, and it covers 5 square feet. So how am I going to make sense of what's happening here? Okay, well, like I know from the last thing, what was it, 9 point, I've forgotten already, 9.3, okay, by 10 to the 5. Or really whatever answer you declare there. That's the total area in square feet. So I'm basically saying, look, if that's the total area, and this is, this tin covers 5 square feet, I'm basically asking how many 5s in this big number. Now, just for the calculator practice, okay, I'm going to clear this. So what was it? 9.3 times 10 to the power of 5. That's all divided by, so I can make the fraction. I programmed it right, which I didn't. I can get around it. It's going back here and dividing that whole thing there by 5, and I get 186,000. Okay, that shall stay here. I don't know why it flicks to the next page when you press the thing, because the pen function goes away, but whatever. So that 186,000 is the amount of litres I need. Now, that's very easy to fall into the trap of thinking you're done. But they're asking us how many tins of paint. Each, they're basically asking how many 25s in this number. It's showing that calculation there. Now, I think it looks like it would work out evenly. Okay, let me divide that by 25. Yeah, I did, okay. Just sometimes what happens there is the number there might be like 7439.5. Then the answer, you have to round fully up, because you don't open a tin and use a drop of it. If the tin's open, it's opened. Okay, so it's a small point. It might just trick you and lose your mark. But there's only 5 marks worth going here, so it's not terribly many marks to lose. Now, the last one here is a 10 marker. I like these questions. Okay, power questions, just whatever number of powers of rules of powers that are important that you have a handle on. This is just, the trick here simply is these base numbers have to be the same. Now, currently they're not. So if I go, look, well, I like that 2. So that's 2 to the power of 9x minus 1. But this 8, I want to change that. Now, I would say change it down to 2s. So if I go, look, how else can I say 8? Well, it's the same thing as 2 to the power of 3. And this is an important concept in maths. Like, knowing how to express something in many different ways is one of the reasons that I'm not good at maths, in a sense. I don't see that very easily. Others do. Like, they can really see, oh, I swapped that for that, and then it simplifies, and then they move on. I'm often staring at the page for ages going, what the heck do you do here? And just, don't have that good sense. But if I see that here, okay, and just, again, it's not a huge leap to go, look, and to remember, try express one of the numbers in a different way. That's a fairly obvious one, okay? And that's still to the power of 2x. So now the base numbers are going to be the same, but I've created a little problem here. If you ever see brackets, you're not sure what to do, multiply the brackets. Now, in this case, this is the power of a power, okay? And what I'm going to do there is just multiply the little numbers. So it's 3 times 2x is 6x. Now, once you get to this point, if you have the two base numbers are the same, and they are now, I can ignore them and just equate the powers. Now, if I've just all I've done is focused in on the powers and made them equal. Once I get to this point, I go, well, this is an equation of one unknown. There's only x's. Now I have to do a bit of work. So I'm going to bring the 6x across. Okay. Now I'm also going to bring the number to the far side. So the plus 6x became minus going across. The minus 1 became plus going across. So I've not done anything, unbalanced. 9 of something take away 6 of something is 3 of them. Okay. Then finally, if you're going to bring the 3 across, it was multiplied on the left. It'll become divided on the right and divide into everything on the right. Now, that just happens to be 1 in this case. And that's my answer. Now, if I want to, I can check it. Is 2 to the power of 9 times the third minus 1, is that equal to 8 to the power of 2 times the third? I'm not going to do it here, but you test it, it should. If it does, they are equal. It's always a check. If left side equals right side, it's correct. Okay. So anyway, that's it there, just on in a prettier version. Okay. So that was the Leaving Cert Order Level Paper 1, Question 4 for 2020. If you want to copy these notes, just send me off an email to shanetry@gmail.com and click subscribe to see other playlists. Okay guys, thanks a million.